Good morning to everyone. Today I'm going to discuss about intermediate course. So you already know that is the one of the phase of the compiler. Okay, right? So before this, once I can explain that what is the input and what is the output. If you're taking the phases of the compiler, lexical, syntax, semantic. After that, the next phase is the intermediate code. Okay, so here it can generate the tokens. The tokens input will be taken these phases and it can generate the syntax tree or parse tree. Okay, nice. The next phase is the intermediate code. That means here the intermediate code is taking the output of the parse tree. That means some graphical representation is the input and that is the input here. And what is the output means some codes will be generated. That code is helpful for generating the target code, right? So finally, we can understand that input is okay graphical representation and output is some codes, right? So now how these codes can represent? There is a four types of representations. One is the syntax tree, and second one is directed acyclic graph, that is only called DAG, right? The third one is postfix notation, and the fourth one is tree address code. So these four things I will explain with the example. The first one is the syntax tree, right? For example, A plus B. That means A and B. That is the representation of syntax. So here I will explain one example. A equal to B into C minus D plus B into C minus D. Okay. So C minus D. And we're minusing minus. And we're multiplying with B. Same part. Based on their operator preference, this will execute first after this multiplication like that. And we're multiplying with B. Now we're adding and we're assigning to E. That is the syntax tree. That is the first representation. Right? If you want to write the syntax directed translation, it is a node P1. It is a, for example, if you take lengths. So how to write C? For P1, that is a leaf node, right? So we can write as the MK leaf. That is identifier is the C. For example, for P2, okay, that is the identifier D. For example, P3, that is not leaf node. So we can write as the MK node. Operator P1 and P2. Like that. We can write the for all the nodes as STDs. Okay. So now we can discuss about the DAG. Okay. What is the meaning of the DAG? Means it is used to remove the redundant expression. Otherwise, it is used to remove the common sub expression elimination. It is the common part. That means this part is the common part. No need to represent in the DAG. See now, T, B. Okay. And no need to write. We can represent this symbol. To J. That is the DAG. So once again observe that what is the difference between the syntax tree and DAG means it is used to remove the redundant expression. Okay. See the third part is that is the postfix notation, right? So our example is B into C minus D plus B into C minus D. Okay. So what is the meaning of the postfix? For example, A plus B means AB plus like that. See here, first one, right? CD minus, none minus, next to B into. Same, CD minus, A, and minus, sorry, and multiplication. After that, we're performing the addition. Now, we're assigning the equal. That is the output of the first loop. That is the third thing. Okay. So, the fourth type is three address code. So, here three types are there. quadruples, triples, indirect triples. These are the three representations. See our example A equal to B into C minus D plus B into C minus D. First I can write the three address spots. C minus D, T2 equal to minus T1 this part. B into T2 again P minus D minus T4. Okay. T6 equal to P into 5. T7 equal to this one. So T3 plus T6. And finally A equal to T7. Okay. We are not applying the DAG. If you are applying the DAG means no need to write this part. So T1 equal to C minus D. Tt equal to minus T1. T into T2. That's all. T4 equal to T3 plus T2. And A equal to T4. That is the DAG output. And this part we are removing. So now we see, okay, leave it. We can discuss about the quadruples. We are having the four fields here. One is the first representation. Operator. Okay. Operand 1, operand 2, and the result. Okay. For this statement, I will explain. Operator. First operand D and result will be there T1. Next. And next one is unminus, right? T1. Result will be there at T2. And next multiplication B, T2 result will be there at T3. So for fourth statement, minus CD T4. Okay. And next T5 unminus result will be there at T5. And multiplication B T5 result will be there at T6. Try to understand. Addition T3, T6 result will be there at T7. And assignment operator A result will be there. Also, here operator is the T7, result will be there. That is the representation of the quadruples. Okay. So now we can discuss about the triples. So only three fields will be there. One is operator, argument 1 and argument 2. There is no result field here. For indication purpose, I'm using the statement number. Okay. See for first statement, this one operator argument 1. There is a statement is 0. Okay. And unminus. Okay. So that is T1, right? Now T1 is there. It's 0 statement. Next B operator must argument B. T2 is there at 1. Statement number 2. Okay. For C minus D minus CD. Statement 3. Minus T4. Right. Unminus. T4 is there at statement 3. Okay. That is the fourth statement. B. T5 is there at 4. Okay. See here our multiplication operation. That is B. Okay. And 4. That is statement 5. T3, T6. Okay. So plus T3 is there at the second statement. T6 is there at 5 statement. That is a 6. Finally, A equal to T7. T7 is there at 6. That is the statement 7. That is the triple representation. That is the second one. And the third one is indirect. Indirect triple. That means pointer to triple. Same fields will be there. Statement number, operator, argument 1 and argument 2. Okay. And what is the pointer to triple means? We're using the one more table, sequence number, statement number. See here, I can start statement 20 minus CD and unminus C 0, right? Here we can represent a 20. 21 statement. Next 22 statement means B is the 1, right? So 21. And next 23 minus CD MIDI. 24 statement and minus 23. Next to BT5, right? Multiplication BT5 means 24 statement. That is the 25. And next T3, T6. Okay, so plus T3 is there at a 22 and T6 is there at a 25. That is a 26 statement. And A equal to T7 is there in the 26 statement. That is the 27. That is the final, that is the indirect triple representation. Now, what is the pointer means? Representing the 20 and 1, 21, 22 statement, but 3.23, but 24 statement, but 25 statement, 26 statement, but 27 statement, right? That is the pointer to triple. Pointer to triples, that is called as the indirect triples, right? So finally, if I'm going to the the brief discussion about the intermediate code means, here 4 things. One is the syntax tree. Second one is directed acyclic graph. Third one is postfix notation, and fourth one is the readdress. Here, quadruples, triples, indirect triples. Okay, tree representation. Difference is redundant expression removal. We can remove the redundant expression. Postfix. 4 fields, 3 fields. Here, pointer to trip. Okay, so finally, the intermediate code will be represented in these 4 types of the representation. Okay, so it can take the input is the graphical representation and generate the output is the code. That code is helpful for generating the target. Okay, right? So that is the representation of the intermediate code, right? So like that, the machine generating code can be represented in these 4 forms. So thank you for watching this.